Hello and welcome to this video on multiple correspondence analysis using Stata. In this video, we are going to cover the basics of MCA, its applications, and how to perform MCA in Stata. First, we need to understand what is this we call multiple correspondence analysis or MCA. So, multiple correspondence analysis is a multivariate technique that allows us to analyze the relationship between categorical variables. It is similar to principal component analysis. I think most of us have interacted with this BCA. So MCA is similar to principal component analysis, but instead of analyzing continuous variables, it works with categorical variables. So that's how you differentiate multiple correspondence analysis and principal component analysis. So one analyzes continuous variables, the other one analyzes categorical variables. And now MCA is commonly used in fields such as market research, social sciences, data mining to explore the relationship between variables and identify patterns in data. So before we just move on to this application, because I'm going to show you on how to do this in Stata, first let me explain something on the data that I'm going to use. First, as you see on my screen, I have a data. Actually, this is a heart failure prediction dataset from Cargo. I also attach all the files that I'm going to use in this tutorial. I'm going to attach them in the description below so that you can be able to access them. So including the this data source ring for the data. So as you can see, the data actually has two variables, and we are not going to use all of these variables because some of the variables are continuous, but we are only going to focus on categorical variables. So if I move to this data, you'll be able to see we have something like age, sex, chest pain type, resting, PB, we have cholesterol, and so on. So actually for our analysis, we are going to focus on sex. We are going to focus on this one, second, third, fourth, 50, and the 61 is here, fasting BS. So for the description, the area you can be able to see like the goal fasting base just fasting blood sugar. So one if the blood sugar is less than greater than 120, zero otherwise, and so on. So we have resting EGZ, is ECG, which is resting electrocardiogram results. So we have normal, wave abnormality, and so on. So those we are going to focus specifically for the categorical variables. So there are some steps that I've carried out on this data preparation, because you can't use this data direct. There are some data preparation that I need that you need to call out first before you prepare your data for this multiple correspondence analysis, or what you call MCA. So now let us move on to how to perform MCA in Stata. So if I'll just open my Stata like this, so first is the data preparation from steps that I've carried on this data. So you'll be able to see this the original data which was in the CSV file. From there, I substituted this data into two. I separated it into two. We have continuous features for BCA. So I was able to prepare that to separate that to BCA data, and the discrete features for MCA. So this is the data actually we are going to use. We have sex, chest pain, nesting, age, ECG. We have exercise, angina, ST stroke, and the fasting BS. So this data I saved it as MCA data.dta. Then now the data preparation transformation. So remember that the data actually is in string format, but we are supposed to put it in such a way that is categorical. So we have to convert first of all the first BS from numeric to string. So using this command, and later on we encoded them. So this first thing BS. So actually I was encoded it to row and high. So and later on sex it was encoded as well, and the other five categorical variables. So entirely now the final data that I'm going to use to perform this PCA in Stata is what we call heart failure underscore MCA.dta. So I'll also attach it in the description below, so that if you don't want to undergo maybe all this process, you can just use this direct and practice this PCA in your machine, in your Stata. So now let us move direct to that. So this is the data that we're going to use in this tutorial, and I'll be able to learn that, execute that, and have this data. So you'll be able to see this data, like we have sex, you can be able to see sex at this point and sex at the other end. So like if you are keen, you'll be able to see this one are actually in maroon somehow, and the other one is actually blue in color. So this the original data was in this format. So these are strings, now these are in categorical format. So if you want to prove that, you can just go to your data like this, go to data, variable labels, then hide total values. So you'll be able to see now this data is purely categorical. Now it's ready now to be used for MCA. Now we will use the MCA command, which is part of actually command in this tutorial. So what you do the first, before you do anything, you are going to use to install the package. So watch my previous video on how to do what, to install the package, but this is the command for that. So this is the first step, install MCA. So after we install the MCA package, the next thing that we are going to do is actually is what we call, we are going to start with MCA direct. So we are going to perform MCA direct. So in this, we are going to use this command MCA and select the variables. So I'll go back here. As I said earlier, we're going to focus on 3 variables. So we start with this first thing B. I think this is the first one. The second one is X. Just bin type, last thing ECG, sorry, access angina, stop, and I think that's the last one. 1, 2, 3, 4, 5. I think I've remained with 1. Yeah, actually, sorry, there are 5. So I'll just copy them like this. I'll just even cut and paste them on our do file. So you paste them there, just like that. So at this point, comma, so you need to mention to specify the dimensions. So by default, if you don't mention the dimensions, actually it gives you all the dimensions. So if you mention, like if you specify the dimension, like in this case, let us say 3. Now we are telling Stata that we want only 3 dimensions instead of all of the dimensions, something like that. I mean. So after this, I'll just highlight this command, this code, and execute. So as I was saying, this is a step by step tutorial, so I want you to understand everything. Good. So you'll be able to see now we have our multiple stroke joint correspondence analysis. The method is part adjusted initials, and you'll be able to see the number of observations, the number of access, total inertia, and we have dimensions. So you can be able to see all the dimensions here, categories, and so on. But if I look at this, you'll be able to see like this table is actually, it's good maybe we compact this. At least we have one table instead of having this kind of splitting of the table. So what you do, just go back. If you want to compact that, go to that, copy that code, just like this. Repeat the same, but this time I want us to use compact, just like that, and highlight and execute, just like that. Good. You see now you have the next one. The next step, when we use compact, everything will be compacted, like we are wrapping the output. So you see now in this we have dimension overall, we have dimension 1, dimension 2, dimension 3, or they are compacted together. So you see that's how you can use that compact to do what, to have wrapped output or the result. So that's the first step. That's how you do the MCA once you have prepared your data. So that's the first thing. Remember, in this tutorial, actually, I'm not going to focus on maybe interpreting the result, like the output and so on. Maybe that one will be in our next video. But in this one, I'm just showing you on how to carry it out in Stata. So after doing that, I want us to use what we call if you realize, if you are keen, if I go back here, you'll be able to see the method. So we have different methods when you are using this multiple correspondence analysis. So this is one of the method. This is a default method. Actually, this is a default method. We have another method like joint. If you want to specifically to do joint correspondence analysis instead of maybe multiple. Now there's another method that I want to introduce to you, which is called indicator method. So what you do in that case is this. Now let us go to use indicator method. So what you do, we'll just copy all of this. We are going to use compact format also. Copy this and let us paste them here, just like that. So after this, after having this, actually, it's after here, we just key in method into bracket indicator, just like that, to bracket indicator. So if now we do this, we highlight and execute. So you realize if you go to a result window, you'll be able to have, you see now, here the method is indicator matrix. So number of axes is 3, the dimensions you can be able to see is 3, but you see all the like it shows, this one shows the entire dimensions in this analysis, like the entire dimension, the total dimensions we have is 7. But remember, even in the initially we restricted it to 3 of them, so you can be able to see the the dimension for the all the variables under the 3 dimensions and the overall. And another thing is, if you can be able to see, like there's something changing, like the total inertia when using indicator matrix is actually 1.4, but when we use the default method, it's actually 0.03. Actually, you can say 0.04. So you can be able to see the changes that do happen when we change this method. Now, that's the second method, which we call the indicator method. Now, what if you want to do specifically what you call joint correspondence analysis instead of multiple? So what you do, now this time we want to do what you call joint correspondence analysis. What we call JZA. Now, to use this method, we'll use the same variables. Copy these variables, paste them here. Then now for the joint, actually we are only changing the method. So wherever we have this method, where we have the method, we can just change it like this method. Now instead of now indicator, we use joint. Joint, like that. So when we highlight and execute this, so if you go to our result window, you'll be able to see a nice, okay, you will be able to see multiple correspondence methods joint JKI. You'll be able to see it is total inertia, also how it looks like, the dimensions are 3 and so on. So this is how you do the joint correspondence analysis. In some cases, if you have let us say you have some variables, we normally call them supplementary variables, something like sex, maybe gender, like it's actually it's also the gender. So gender, maybe it's something like what you call demographic characteristics. If you have demographic characteristics on your data and they're in the right format, in categorical format, you can include them in this analysis, like what you call control variables. In other when we are doing maybe multiple regression and so on. So for you to do that, I want us now to copy this. So we want us to include the supplementary demographic characteristics. So this time I want to include this sex as our demographic characteristic. So remove it from here, from the main analysis. Then I included now under this compact. The compact is I just actually do this, move this like that, and so this means it's a continuation of code. Then we now include now let us say the method. See, we are using this the method joint. Then supplementary. So if you want to include those supplementary variables, this is the format. Then so it means demographic characteristic. So in this case we have sex, just like that. So we just highlight this and execute. Perfect. Now you'll be able to realize from actually some changes are being done, like you can be able to see the changes here, and now you realize at the end of this we have demo. So supplementary variable demo, you see. So we have sex, which is fm, male and female, you see. So if you have so many, if you have like 2, 3, 4 and so on demographic variables, and you want to include in your multiple stroke joint correspondence analysis, so that's the format and that is how you do that. So let us assume we have done our required correspondence analysis based on a method maybe preferable to our data. Now we want to do some post estimations, like we do the graphs, we do some the predictions and so on. Now let us go direct to what we call post estimation. Post estimation like that. So and in this case I want to start with predict. Let's start with predict column coordinates, predict column coordinates and row coordinates, just like that. So to predict that, I want us to do predict, then a1, a2, then score. So we are going to use actually this variable first thing z. So where is it? It's here. Okay. Control V. Then we do the same like this, copy, paste. So column and the row. Now this is what you call the next one is row. So row 1, row 2, row 2. Then here instead of this, now we'll use row wise, row scores, then normalization. So we use the now principal option, principal, just like that. So I just highlight all this and execute. So if you go to our result window, be able to see that we have done some predictions. And now if I go direct to my data, I'll be able to see that I have added the column coordinates and the row coordinates at this point. So you'll be able to see them. So these are the changes that we have made to this data. Now let us say we want to view some statistics, like so we want to view next we want to view the coordinates, view the coordinates and the sub inertia. Asia, like that. So we want to start with the first one. We start with sub in Asia. If we want to sub in Asia like that. Now this one, actually this code, it displays the matrix of Venetians of the active variables, but this one is done once you use JCA method, that is joint correspondence analysis. So it works only when you use that method. So if you use the other method like the default one or the indicator matrix, then now this will not be a lucky day. This will not work out. So this will only work out once we have done the correspondence, joint correspondence analysis. So and this one displays now the matrix of Venetians of the active variables. So this is the one we are that are in the data. So if you execute that, I'll be able to see that. So you can see sub inertia, the combustion of total inertia. So you see these are the variables that are present in my data. Remember the last joint correspondence analysis we used. So the SX at this point was as a supplement variable, so it's not included at this. So these are the main. So and you can see this is just a matrix, the matrix. Now the second thing I want us to do is the coordinates. We want to estimate start command, then we estimate the coordinates. I'm using to start something like that, statistic, that, and the execute. So if you do that, you'll be able to see the column statistic and the standard coordinates for all the variables in the data. You can see the mass, the distance, the inertia, dimension 1, dimension 2, dimension 3, and all the variables for like each category. In each variable, the category. So all the statistic, column statistic, and the standard coordinates are being displayed at this point. And the remember our supplementary variable was demo, and also it is displayed at that point. Now let us say we want to display the summary statistic. We want to display the summary statistic. You use the same code, the command I mean, then summarize. And this you summarize, summarize. So that you just highlight this and execute. So this will give you the summary statistic of your variables that you have in the data. So remember, it is a categorical data, so the minimum is 1, the maximum for fasting B, so it's 2, 3, 2, 3, 2, and so on. So and this is the mean of each and every variable that we have in our MCA, more what you call multiple correspondence analysis. Perfect. So that's some of the post estimation that you may carry out on your MCA analysis. And now let us have what we call the plots, which is also important here. So we need to have some graphs here. So in this we normally call it as pie plots. Pie plots. So the first we just start with MCA plot. You can use this option as the default one. Let me do this as the default one. So MC plots, you execute like that. So this one will give us the pie plots of variables that we have in the data. And if you want, okay, let us wait for this graph. Also, actually, it will give us remember we are using pie plots. So like 2 graphs, we have 4 variables, we have 4 different graphs, but in the same page. So like you see in this case we have 5 variables. So we have demo, graphic, supplementary variable, which is the demo, so male and female. So you can see the coordinates, the MCA coordinate for all these plots. So dimension 1, dimension 2, we just at 4. That actually dimension 1 horizontal explains 59.5% in Asia, dimension 2 vertical explains 34.3% in Asia, and so on. Now what if we want to overlay this graph? Like we have one graph like this, but we include all of the variables in it. So what you do is you go back to your do file, and then like this now you start say, let us say we want MCA plot, And in this case, I prefer we use two variables just for illustration, I mean. So I'll use this fasting B, fasting FP, sorry. Then now the color, so let us differentiate them by the color. M color, we can say red. M color, red. Then M label color, multiple label color is color red. Then we move to now the next variable. So we use, let us say we use just bin type. Just bin type. Just bin type. Then we have M color. It's blue. But let us use blue. Then now we use an option of off array. Just like that. So if you do this, copy and execute. Oh, sorry, just been merges none of MCA variables. Sorry, actually remember this one now will work specifically for sorry, for the multiple correspondence analysis, but not the joint. So I'll have to go back. Before we execute this, we have to execute the MCA, the default one. We can decide to use the default one here. Yeah, it's here. So you see that one works when we use multiple correspondence analysis, not joint. So after doing that, I'll go back again and execute this. Then you execute that. Then so let me see. Just bin B. Okay, I'm trying to figure it out. Okay, let us see what we have now. Just bin matches none of them see variable. Okay. Let's see. So we have so it means I did not include just bin in our sorry. So okay, we did not include it here. So let me use, instead of this just bin, let me replace it with this. So it seems now I did not include that in my analysis, so that there's the reason as to why it gave me that error. Good. So if you see now, we use the second one. Now we'll be having MCA coordinate plot for fasting B and XS and Gina. Now you'll be able to see now, like, instead of having two different dimensions, many plots, you have one, but they are off array. So you'll be able to see the coordinates at this point in one single graph. Now let us do this last plot, what we call there's something we call dimension projection plots. Dimensions projection plots. Now for this one, what I'll do is actually must copy this, just copy all the variables that you have used in your analysis, like this. Copy them. Now paste them at this point. Now you use MCA projection command, then you paste those variables like that. Then now you highlight this and execute. Perfect. So you will see that we have some plots here, which we call MCA projection, dimension projection plots. Now for the as we are waiting for this, remember the wood. You see now this is what we call the MCA projection plots. So it's a line, they are nice graphs as you can see. This is actually for the project something like for the projection. Remember, the pie plot shows the variables as points in two-dimensional spaces with the distances between the points representing the relationship between the variables. So the arrow also represents the dimensions and the angle between the arrows represent the correlation between the dimensions. So actually remember the main objection or the main aim of this MCA is just to show the relationship between categorical variables. So all the connection, the graphs, now everything will link to what you call the relationship between those variables, what you call categorical variables. Then now, actually now this is up to this point. This is how you carry out multiple correspondence analysis in Stata using appropriate in the data set. And actually, this video or this tutorial was just to show you on how to do it practical. So, and on our next video, we'll take our time now to interpret each and every output that we get from this what from this analysis. So for now, that's it for this video on multiple correspondence analysis using Stata. And if you are new to this channel, kindly consider to subscribe and share for to your friends and colleagues and so on. So I hope you found it informative and useful. Thank you for watching.